So first, I introduce myself quickly. So I'm working for Safran in the Safran landing system entity. So I spent my career mostly in aerospace, starting in Dassault aircraft, and some time spent in consulting, and but mostly in production and repair environments, and always involved in a new technology. And I would say smart factory is my favorite subject. So today, the purpose is, I don't want to talk about all the scope of smart factory, even I'm covering all the scope for my company. I just want to focus on augmented reality, which is one aspect of smart factory. And in particular, all what we did regarding MRO. MRO means maintenance, repair, and overhaul, for those who are not familiar with aerospace wording. So I will explain more. I don't want to talk too much about technology by itself, just to explain more why did we develop augmented reality, in which cases, and what is a successful approach for this kind of project. A brief presentation of Safran, very quick, just to explain the context. A brief overview of augmented reality, but we could talk also about virtuality, but today I will focus on augmented reality only. And I will talk more about the name project, which is ARGO, Augmented Reality for Ground Operation in a Safran landing system, the key step of this project, and the lesson learned. So Safran is a group of 81,000 people worldwide involved in engines for aircraft, for helicopter, for rockets, equipments. And in my case, I'm working for a landing system, which is 7,000 employees, 18 locations worldwide, and with repair activity, MRO activity, which is around 20% of the turnover, which is quite important for the company. So there is no interest to go further in the presentation of the company. The context is the following. It's quite important because today, as you know, aerospace is suffering a lot from COVID, and that means we had to postpone some investment because we have cash constraints. So we had to adapt to the slowdown of the business, to have new practices, in particular to have some alternative to travels. So that leads to new needs in terms of remote assistance, for example. But what I want to say is, globally, whatever the situation, we need to, even we have less cash to invest, we need to be more competitive against competition. As soon as the situation will recover, the competition will be harder. That means we need to continue our journey and to use more digital to be more competitive. The digital is definitely a lever to be competitive, either in design and industrial area. So this is a challenge. So when we talk about augmented reality, it's part of a global picture. This is a summary of the axis of the smart factory approach, from digital continuity, from the PLM to connecting the machine to get data and to use the data, advanced processes, closed door machining, additive manufacturing, which is more to come, but also a lot about digital inspection, which is key in our business. Process automation, of course, we don't produce 2,000 products a day, but we have some interesting development about robots, IoT logistics, augmented operation. This is a topic for today. Also initiative toward a responsible factory. So we try to develop, to modernize assets to use less energy. And also some development toward new services. globally, we try to mix short-term approach with topics, subjects which are mature enough to be deployed with validated ROIs. There is no other solution than demonstrating that we don't want to make only a proof of concept. But midterm, anyway, in parallel, which we continue to work with a research and technology approach to grow the maturity of new solutions, to be more disruptive and to have more added value solution in parallel. So we play on two different horizons. So augmented reality and virtuality is a technology which is gathering several areas, in fact. Augmented operation, of course, is the main target, but we also support more digital inspection because today it's a very manual activity, depending a lot on the skills of the operator. We use virtuality for simulation, of course, and also for training. And remote assistance could be considered as part of augmented reality, augmented operation, sorry, to support remotely people. So that means augmented reality is one key lever for competitiveness and very important aspect of a smart factory. We have a global roadmap looking similar to LT1. It's quite similar. But today we work on paperless, and this is a range of topics. So the very first priority is to have full digital continuity from the PLM, the design of a product, down to the shop through the MEDS, MES. And also, we work a lot on the improvement about quality, meaning that we look for solution to have adjudication about quality, semi-automatic, at the target more automatic. But augmented reality is part of augmented operation, is supporting some paperless initiative, something in addition to the MES, using 3D capacity to help people. It's part of the operator 4.0 approach, meaning giving the operator in real time the appropriate instruction relevant to the product and in line with the configuration. And everything is looking for a more smart factory toward other subjects. So this is just augmented operation is one aspect among others. So I'm going quick. In Safran, we are using augmented reality and virtuality for years now. At the beginning, it started more in production and control. You have a few examples in engines, nacelles. Virtuality is used in design and industrialization. But I would say that in repair, it's more recent. And I was one of the players in the group pushing a lot on this area. This is what I want to develop. So now I can say that augmented reality and virtuality are fully integrated in a smart factory, or some are saying manufacturing 4.0 roadmap, but is that still the same? Okay, so now let's move on this Argo project. The question may be, why did we focus on use cases in MRO, repair activity? First, for those who are not familiar, maintenance and repair in aeronautics is quite complex with not so much repetitive operation. We work on product design 30 or 40 years ago with a wide range of configurations to maintain. An example, a landing gear for an A320 today coming in a shop, you could have 40 different configurations for one subset of a gear. You could imagine a combination. So each case is different, but you have to play with one single maintenance procedure. This is a challenge. The fact also is that digital was not so much used so far in repair. So there was a lot to do. So if we listen to the customer, the customer who are buying a repair are looking for some disruptive solution, because sometimes they repair by themselves, but they buy a lot to to maintain their product. So they are looking for more digital solution for services, such as repair. And also there is a key problem in aerospace, that the complexity of the repair is asking for skilled people. So there is a shortage of skilled people because of growing of the fleet. Of course, the COVID has slowed down a little bit the growing of the fleet, the growth of the fleet, but now we're still missing competencies. So the objective, either for Safran and the customer, is to reduce the cost of the repair, to improve the quality, to do right first time. It's very important. We are not playing, we are playing with things which we are flying. There is a security aspect. We want to help a customer to ease the diagnostic and to ease the support in service of the product. And also there is a key requirement to ease the collection of data about the behavior of the product in the field, to improve a product in the frame of what we call health monitoring approach. So this is the expectation of the market and what we are looking for as a company. So before we had on the left, you see an image of what is the current documentation. As an OEM supplier, we have to, per regulation, to provide standard documentation explaining the product, the margin when you remove corrosion and so on. But this document is not easy to understand. There is an effort of the technician to translate this documentation into instruction in the shop. Some documents are calling others and so on. So there is a mental effort, a need for high-skilled people to translate this official documentation into actual instruction to be done on the gear and the specific configuration you are receiving for repair. So everything is driving additional cost, complexity, and a risk of errors, because as soon as you ask people some additional mental effort, you introduce a risk of errors. This is the context, and it was a start. So after we introduce the usage of augmented reality, is where there is an interest to provide 3D assistance, more visual instruction, more detailed instruction, with a step-by-step instruction. You cannot miss a step. You have to follow the script. You have a capacity to also to assist people remotely. Quality has been reduced, so no more non-quality exported to the customer. You have capacity, because you have a camera, to record everything you are doing, what you see on the gear when it's coming in the shop. There is no more any misunderstanding with the customer, because you record all the data. You have a full traceability, because traceability is very important in our business, because at the end, when you sign off the document telling that the gear has been repaired according to the documentation, you have a proof that everything has been done per the documentation. And also is a true answer regarding versatility. Versatility is very important. Today, a component has to be repaired in 10 days for a small component, and for a gear, a complete gear is 45 days. It seems long, but it's very challenging. So you have to, one key to keep to respect the lead time is to have full versatility of the people. So having such assistance is very helpful to have a more efficient learning curve for new people, but also to maintain the knowledge beyond what is written in the documentation. And of course, behind that, there is a productivity, right first time. You have less rework and a better quality and a better quality of the service as delivered to the customer. So this is the purpose. The story. We started very simple. We started with a student, with a partnership between a school, an engineering school in France, Aerospace school, and Diota. Diota is a partner with a very good augmented reality technology. So we did a demonstrator, and it was a very big help to promote the technology, because in 2017, many people were considering this as not a toy, but something nice, but with no demonstrated value in our business. So we did a job, we make a world tour, we did show this solution to more than 120 customers, and we were convinced at the end that there is a big opportunity to improve and to provide something new to the customer. That's why the project Argo was born. Then we enter a phase with pilots. Pilots, compared to a demonstrator, a pilot is a use case in a true environment. So we did that in 2 shops in France and UK, and then we really demonstrated the value in the shop. And we extended the communication on the use cases, and the project started to be known, and the manager, the decision maker, started to believe in the project. And we had a roadmap. Then we moved to the industrialization phase. We did not make only pilots. So we extended the usage, and we are still in this phase in UK, in Singapore, in Mexico. In parallel, we continue to develop research and technology to develop more advanced use cases. Of course, with the COVID, we have lost more than 1 year, but the project is still there. And the COVID did have some interferences, but now we are more in the reuse of the best practices, all in the group. And from MRO repair activity, we did reuse in the production, because there are similarity around inspection. And we have a roadmap up to 2025 with an extensive deployment. And it was very successful, because at Safran level, we created a platform to do some capitalization cross division in the group, and to utilize some skills and specific development. Okay, an example of a demonstrator, very quick. This is a true example. We have what we call in aeronautics a service bulletin. It's an instruction to remove a pin on a gear. So we did a demonstration of how we could replace a paper document with an augmented reality devices. And it was very demonstrative. Other example in repair activity, in Molsheim in France, we develop assistant to assembly and final inspection. You know, on a gear, you have harnesses, pipes, and so on. So visually, you check, you will see in the video, you see if the harness is at a good place, if you are not missing parts and so on. In Gloucester in UK, we did some incoming inspection, because usually what you receive from the customer and what is displaying in the documentation, there are some gaps. So if you don't have a very repetitive process assisted, whatever the operator, to to check that what you receive is what is the gap between what you see on the product and what is announced in the documentation. You may have some dispute, you may miss some work to be done in the quotation. And at the end, anyway, you have to deliver the complete gear with all missing parts. So we save a lot of money on that. Okay, that's some examples you will see in the video. What else? We have developed a vision. The vision is we start from official documentation coming from the OEM. We develop some digital instruction plus some used as a training. Okay. Then we develop two kinds of assistants, either mobile using tablet or glasses. Not so much deploy so far because we didn't find the appropriate glasses. And then more fixed workplaces in the shop, just an add-on to the existing MES computer screen, adding some additional augmented reality functionality where it makes sense only. Some places there are some projection capacity and possibility to connect the tool. You use a torque system, you measure the torque. You have developed in parallel remote assistant capacity to assist people remotely. And at the end, what is important that as soon as you develop your repair, you use the instruction, digital instruction, you record the information as you progress. And everything is collected and the report is done automatically because it was very time consuming, something which is reported to the customer and also back to the engineering because we collect data, very useful to improve our product. It's more easy, it's easier to play with digital data than papers. This is the vision. Globally, we work on three main objectives. One, first is to have more competitive advantage on MRO activity and production. We talk about 8 to 12% efficiency on man-hour. Full digital traceability, right first time, the big impact on quality, automated data collection and report, versatility, so I did explain that, but also some possibility to develop services for a customer. If we're capable to do these things internally, we are capable to provide a customer some digital version of the documentation with more added value. And also some possibility to extend and to provide some training, either augmented reality, more virtual training. So what is very important in terms of methodology? That it's very important to merge three aspects. One is human appropriation. Added value of a feature, you have to provide something with an added value or there is no benefit. And also technology integration. So in other words,
2 more minutes of the presentation. We have questions, please, Francesca.
Okay. Benefit of task, which is important, accepted by the user, and also maturity of technology. You have to play with three axes. I need to keep some time for video. So everything has been written in a white paper. This white paper is accessible to everybody through the DIOTA site. This is something I did write with DIOTA, and it's explained all what I explained to you today. So you have an help and best practices to deploy such technology. Lesson learned quickly. This technology is quite intuitive, but the development must be done with a shop law. Productivity has been demonstrated. It could be in a range from 8 to 20%, depending on the level of expertise of the operator. Very promising in quality. We can talk about a kind of a digital poka-yoke sometime. It's a great help to go toward automatized inspection. There is synergy between repair and OEM production. And the pilot can develop in 4 to 5 months. So provided you have a good skills of a project leader. But you need to anticipate availability of people in the shop floor because you need to develop with the shop floor. You need to have 3D model, but you can scan, it's feasible. You need to check with IT any details, license, configuration, hardware compatibility. No, please involve the IT very soon. The project leader must have double skills. He must understand the process and have some digital competencies to merge two things. And you need to have at the beginning some awareness phase to drive the good use cases and to copy paste what works very well. So this is the baseline.